All right. Thank you, Tori. Yeah, happy to get started, folks. Thank you so much for joining. And as Tori mentioned, my name is Ben Smith. I'm one of the directors here at GridSME, part of the compliance team that has the opportunity to work on generator owner implementation projects, all sorts of whole host of services to support our clients and associated vendors. Been here about 4 years. Glad to be here. Glad to talk with all of you folks today. As Tori mentioned, we'll tap this discussion today, but feel free to drop those in the chat as we talk through the content. If you have any technical questions that come to mind as we're talking through it, please drop those there. We'll do our best to answer those at the end of the call or offline after. Also, if you see anything that we maybe didn't cover that you're curious about, you can include that as well in the chat. So the rest of the content mostly will be covered by Todd Rhoades. I'll let Todd introduce himself and then he'll roll into the content, and I'll hop back in toward the end.
Thanks, Ben. So I'm Todd Rhoades. I'm an engineer in the GridSME's GO implementation team working with Ben. Focus on development of evidence and collection and summarization of evidence supporting the NERC registration and compliance aspects as a new generation owner comes on board and moves forward. So look forward to conversation at the end of this. As Ben said, if you have technical questions, please drop those in the chat or bring them up at the end. Content could get very technical and be difficult to cover within the time frame, but don't want to overlook something that people have questions on. So next slide, Ben. So we'll cover a little bit of background and how we got to this point and what FERC Order 901 has brought forward, and then we'll roll into discussing some of the technical standards and what they're bringing, what the implications of those are for the IBR resources. And then we'll go through implementation timelines of those and how they fit in different scenarios and what the aspects of moving forward to meeting these requirements will be. And then we'll talk a little bit about GridSME's ability to help and our plans on how we will help address these as a compliance consideration, and then move into questions and feedback. So next slide. So let's go ahead and go to the next slide, Ben. So NERC really came into being around outages that have occurred over the last 30, 40 years, that, well, 50 or 60 years actually, going back into the 60s, and brought forth an effort to improve the reliability of the transmission system. The particular things we're working on now have to do with recent outages over the last 10 years or 12 years that have been very large-scale IBR outages in what are often referred to as cascading events, where you saw multiple IBR plants go offline simultaneously or near simultaneously. With the growth of IBRs and the reliance of the grid on IBR resources, improving and limiting these outages became important to primarily prevent some of the largest them becoming larger and becoming more significant. And so NERC has taken investigation of many of these or most of these outages and developed a list of items that were contributors and could be improvements in terms of the quality, data quality and modeling accuracy and coordination of protocols that would improve the reliability of the generation plants. So in October of 23, so not quite 2 years ago, FERC released Order 901, which gave NERC directive to make improvements to reliability standards, specifically around IBRs. So next slide. So what has NERC been up to? So they really set forth 4 milestones around coming out of Order 901. The first was basically developing a roadmap or a plan that was filed in January of last year, January of 24. And then milestone 2, which is our performance requirements aspect, filed in November of last year. And that's what we're going to predominantly focus on. Continue to move forward in improvements and additional standards related to milestones 3 and 4, which relate to data sharing, modeling, model validation, and planning and operational studies that will be coming forth. And it's anticipated there will be a next round of filings in November of 25. Next slide, please. So I'm going to pause here. No, let's stay back on that slide a second. Well, no, let's go ahead to go to the next slide. Sorry. So there are 4 specific standards that we're going to review and talk about today. One is a non-NERC item, which is IEEE 2800, that is really a foundation of a lot of the work that NERC has been doing and the direction that is being taken. And then there are 3 NERC standards, PRC 28, PRC 29, and PRC 30, which directly relate to the ride-through performance or the operational performance of an IBR plant, as well as validation and coordination aspects of the plant and data collection and monitoring of the performance. And we'll go into details of each of those. But I'm going to stop here just a second and kind of go into something I didn't put on slides because I didn't know exactly how to put them on slides. Have had many conversations with people around, in particular, IEEE 2800 and PRC 29, of how do you prove or how do you demonstrate that you're achieving and compliant with the intent and objectives and requirements of the standards. And it's a very good question. It's a very interesting question. Many of the NERC standards you read and you find a list of tasks, and they're very task oriented, and you come through and say, I've got 5 tasks I need to perform and do a reanalysis every 5 years of these particular items. And so those requirements are very definitive of what is expected to be executed to demonstrate compliance. The things that are developed here and what we're going to talk about are not task oriented, but performance oriented. And so as you read through and decipher what these say, there are not it's very difficult to pick out very specific tasks that says I have to do these, I have to do that at this time to maintain compliance. They are, you have to read them and look at them in terms of this is the desired performance, this is the undesired performance, and analyze and look at, well, how do I ensure and what do I do to promote being on the desired performance aspect and minimize that undesired performance aspect. And if you do experience undesired performance, what are the actions? And there are some detailed specifics about what to do around those undesired actions. But it's not as clear as I can plan that in 3 years I need to do these actions. These become a monitored system and a responsive aspect rather than a defined set of details. And it is not laid out exactly how and what you're going to need to do or want to do to continue to ensure that you have your desired performance aspect. So there's an uncertainty and an uneasiness about that. I fully understand that. I've spent 20 years in the electric power industry. Part of that, I spent 20 years in the communications industry. And that this is a typical aspect of the communications industry. So it will take a little adjustment to get used to the ideas of dealing with that uncertainty of what may come forth and what I may have to respond to. But with good engineering, we can push and ensure those likely timeframes are out in the future a ways. We're going to hope we don't have something 6 months, 12 months after the plant goes live, hits COD, to have something come up, and with some good engineering, we can avoid those. But as you get 5 years, 7 years, 10 years out in the future, that uncertainty grows. And so, yeah, there is going to be some unanticipated, unexpected things that will come up. Hopefully that they can be dealt with fairly readily and fairly inexpensively. And we also know this is going to be an evolving standards aspect. This is the first iteration really around these IBR specific items, and I fully expect in the next 5 years we'll see another iteration and see a cycle of improvements. So with that, let's go on to the next slide. So IEEE 2800. IEEE 2800 is a design, it's really a design, test, and verification guide for how to develop an IBR plant. And as part of that, it establishes what the inverter, what the plant capability should be, and it defines plant performance aspects. What I was just talking about is here's criteria on how it should perform. It's applicable utilizing NERC terminology to both Category 1 and Category 2 IBR plants. In specific, it does not limit to a MVA, but it strictly is, it's connected to transmission and sub-transmission. So anything over a 60 kV system. Is this applicable to a generator owner? Maybe. It's not specifically directly applicable under the NERC considerations, but many transmission owners, transmission operators, system operators are including aspects or the entirety of IEEE 2800 as part of their generation interconnection requirements. and on occasion it's operational guidelines. And that can be either directly through reference of saying you must comply with IEEE 2800, or more commonly excerpts out of the standard are rewritten and integrated into their own requirements. There's some benefits to that if you control the language that way. But depending on where you're interconnecting, who you're interconnecting with, there may be aspects of IEEE 2800 that come along with that interconnection. Next slide. So what are the key elements that are focused on? So there's really two different aspects of the operational and or performance aspects of the system or of the IBR plant. One is, how does it perform under quote normal conditions? So normal conditions would be normal voltage, normal frequency ranges, and requires the implementation of power controls around frequency response, reactive power controls around voltage response is kind of the default, although there are some other options. And then it goes into, okay, now that we're in a system disturbance, abnormal conditions, how does the plant respond to those conditions? And typical responses through a reactive power response based on your voltage deviation and as a primary control function, and then you continue to support real power associated with that. And then you have your protection aspects, your voltage and frequency ride through protection settings, and ensuring that we allow the system opportunity to respond to the changes in output and see if the system will recover before tripping. There are also aspects of power quality, general plant protection, and then there is a section on performance monitoring data of what information is critical or important to be able to really evaluate, is the plant performing in the way it's intended, and if not, can we identify what aspects are not performing in that realm. Okay, next slide, please. So that will roll over onto the NERC PRC requirements, and we're going to start with PRC 29. This is applicable. So this replaces what used to fall under PRC 24. So PRC 24 will no longer be applicable to IBR resources. The caveat to that is wind types 1 and 2 will remain under PCR 24, as well as synchronous generators. And so PRC 24 does not go away. It's just the IBR elements and plants will now fall under PRC 29. So what does this standard require, or what are its aspects? So it requires both a design and a performance aspect of the requirement. So as we're focused on geo implementation, we're really focused on the design aspect, and then the performance standard aspect will come down the road as the plant is in production and experiences voltage deviations predominantly. And so we'll touch on that here in a little bit, but there are 4 requirements. First is related to your voltage and your voltage ride through during your or plant ride through during voltage excursions. So when you see a voltage swing up or down, no trip zones, and mandatory operation continues within within those voltage deviations up to certain time frames. Second is then as you're in those voltage deviations, how do you want the plant to perform? What kind of output? What are the controls? How is that going to respond and react as you see these deviations? And that's predominantly, like I was referencing under the IEEE 2800, that is predominantly through going into a reactive power priority mode and supporting the system voltage through that reactive power. Similar to the voltage ride through, there's frequency ride through and excursions. So now we've addressed both the voltage and the frequency aspects as they deviate outside of ranges and when tripping is permitted. So how do you ensure these? Well, that's part of where the relationship between IEEE 2800 and PRC 29 in your design elements help you derive to a design that will perform according to these requirements. And then requirement 4, it's recognized that there's equipment and facilities that were not designed with any of this in mind, and so they will have limitations. So being non-conforming is going to be acceptable as long as you've documented those equipment limitations and explain of why and represent that there is reasons that performance cannot be consistent with the performance laid out in PRC 29. So what is this applicable to? So this is applicable to both transmission and sub-transmission systems. So category 1 IBRs and category 2 IBRs will both be subject to the same PRC 29 requirement and same set of requirements. Next slide, please. So now we'll move over and talk about how do we monitor and what do we look for in terms of performance. So PRC 30 is looking at how does the plant respond to unexpected events. So we've seen a change in the system and the plant went into a response mode. So we'll take a look at that. But this works in coordination with PRC 4, which is a requirement that you look through your protection system of your substation to validate that your protection system operated and responded accordingly. So this is taking that a little further and looking at the outputs, not just the tripping aspects of your protection system, but the response aspects of your inverters also. So again, there are four requirements. The first requirement is a process for identifying when a variation in the output of the plant has occurred, and it's defined as being of at least 20 megawatts and 20% or 10% or greater of the nameplate rating of the plant with a duration of at least 4 seconds. So what does that mean? If your plant is 200 MVA or less, then the 20 megawatt drop in output becomes your driving characteristic. If you have greater than a 200 MVA plant, then your 10% of nameplate becomes your consideration. So if an event or when an event is identified, what is required? So that's where PRC or requirement 2 comes into play, and you must go through and identify your root cause of that, and then evaluate your voltage and frequency ride-through performance and determine is that response consistent with what the performance aspects laid out in PRC 29 are or not. And if you and as part of that, then you document how was your plant's reactive power? How did your plant respond in terms of reactive power? So did you see your inverters go into a reactive uh, reactive power priority mode and injecting a reactive power aspect to the system? And if you conclude that there were some performance issues, then do you need to have a corrective action plan? Is there something required to change the performance of the plant? And then all of this needs to be made available and coordinated with your GO or with your TO and appropriate reliability elements. And then as you look at it, you also need, as a GO, to evaluate, are there design aspects of this facility that exist in other of my facilities that I need to also look at and reconsider and look at if I need to make corrections or additions in those other facilities that may experience similar performance. So if a corrective action is required, you need to develop a corrective action plan, or if there's not a corrective action, justify why no action is going to be taken. And then R4 really is an implementation, execute what you've laid out as your corrective actions. And then, and again, this is applicable to both Category 1 and Category 2 IBR facilities, anything connected to your transmission and sub-transmission systems. So next slide. So to perform that analysis, you need data. So that's where PRC 28 comes into play. This is for IBRs, a replacement to the requirements under PRC 2. And again, except for wind type 1 and 2 will remain under PRC 2. So under PRC 28, there are three main elements that have to be put in place: a sequence of event recorder, which is requirement 1. And one of the unique aspects of this is not only is it substation related, but you also need data collected around your individual inverter units. You need a fault recorder, and that relates to requirements 2 and 3 to be able to collect fault data and support that. And then requirements 4 and 5 are related to dynamic disturbance recording information. There are requirements out of 6 and 7 related to your time synchronization and your data responses and data formats that have to be maintained. And then requirement 8 is a requirement that if you identify your system is not working, one of your elements is not collecting data appropriately, then you have a defined time to return those to service and have them operational and collecting data, or there is an option of creating a corrective action plan if the time response is going to be extended. So again, this is applicable to both Category 1 and Category 2 IBRs. Okay, next slide. So we're going to move on and talk about timelines, implementation timelines. And this is all, our dates are all based on an effective date of October 1st of 2026 for PRC 29 and 30. That is dependent upon a federal registering notice that has to be published before the end of September, but anticipate that will take place. So next slide. We have 7 scenarios we'll go through related to how these timelines line up. So this is applicable to Category 1 IBRs with a COD on or after October 1st of 26, so about 14 months from now. PRC 29 will become required at COD for all elements, all aspects of PRC 29. The same is true for PRC 28 and PRC 30. So that's fairly straightforward that October 1st of 26, expectation is a new facility will be compliant with all aspects of these three standards. Next slide, please. So we're going to go kind of to the other end of the scale of COD that occurred prior to April 1st of this year. So that was prior to the PRC 28 effective date. And this scenario is going to be limited to a single Category 1 IBR. So PRC 29, the design requirements will become required effective October 1st of 26. Requirement 4, which is your equipment limitations aspect, will also be required by October 1st of 26. PRC 28, requirements 1 through 7 has a requirement date of December 31st of 28. So it'll be a little more than 2 years after PRC becomes required that you'll be required to meet PRC 28 requirements, with the exception of requirement 8, which what it really says is if you install your equipment prior to December 31st of 28, you will need to maintain and keep that operational. You do not get to defer that restoration of that until December of 28. And then PRC 30 becomes required effective October 1st of 26, except that your data will not become, you will not have data to really analyze until PRC 28 is complied with. So while you're going to be required to be compliant, you may not have the data to support the actions that go with that. Next slide. So this is similar that the COD is before April 1st of 25, but now there are multiple Category 1 IBR plants. So the PRC 29 requirements are similar, that October 1st of 26 for your design and your requirement 4. The difference comes in on PRC 28 that the December 31st deadline only requires 50% of the plants to be compliant with PRC 28, with all of them compliant by January 1st of 2030. And then PRC 30, again, as your PRC 28 aspects come in place, that you'll be part of, be analyzing and performing associated with the collection of data. Next slide. So then what happens with the plants that come on board COD between April 1st of 25 and October 1st of 26? So from a PRC 29 standpoint, October 1st of 26, they must be compliant. From a PRC 28 standpoint, requirement is a little bit ahead of that deadline of July 1st of 26 for requirements 1 through 7, and again, January 1st of 26 for requirement 8. And then PRC 30 will become a requirement October 1st of 26. So that's our category 1 facilities. So next slide, we'll look at category 2 facilities. So our deadline slides a little bit on the COD after January 1st of 27. So it slides a little bit from that of the category 1. But again, all aspects of PRC 28, 29, and 30 will need to be complied with on COD. Next slide. So category 2 with a COD before May 15th of 26, so May of next year. So PRC 29 requirement for the design aspects of requirements 1, 2, and 3 must be complied with in January of 2027, January 1st of 27, along with requirement 4. Requirement PRC 28 you have until January 1st of 2030 to have your data collection equipment in place, with the exception of requirement 8, which is April of 27. And then PRC 29 will also become a requirement for compliance on January 1st of 27. Next slide. So our last piece is category 2 IBRs, which come on with a COD between May 15th of 26 and January 1st of 27. So from a PRC 29 standpoint, they will need to be fully compliant by January 1st of 27. From a PRC 28 standpoint, they will need to be compliant the later of their COD or July 1st of 26. So July of next year. And from a PRC 30 standpoint, they'll need to comply beginning January 1st of 2027. And I believe that wraps up the scenarios, Ben.
Yep, it does. Thank you, Todd, for covering all those scenarios. It's a lot to make sense of based on when facilities are operational and the characteristics of the plant for category 1 or 2. So I know a lot of folks have had questions around that, and hopefully the group here found that to be helpful. So what I wanted to cover here briefly is just what GridSME's solutions are to support you folks and any other folks that you might feel they have a need for support. So general solutions GridSME can offer through our engineering and interconnection teams or grid integration teams or compliance teams, modeling, managed compliance services, and also through grid security, managed security services. As you can see, we have solutions in place that can support you throughout the project journey. So wherever you're at in the journey, we'll meet you there, and we have the capability to support you with these sorts of activities that Todd just touched on, and or anything else that you're subject to for whether it's NERC compliance or interconnection requirements. There's a lot of requirements out there these days that you need support with, and that's how we can help you there. Specific to addressing readiness for the approach for these GeoIBR requirements that we just touched on in detail. Yeah, it just comes down to readiness reviews, understanding what sites are impacted that you have in your portfolio, or the current, helping you understand the current compliance status of these facilities, what equipments and settings you may have in place already or need to put in place, those recommendations for resolution to fill those gaps in your readiness journey there. Todd touched on it in great detail, but reviews of analyses and performance efforts, activities that can be performed to help you demonstrate compliance with those standards that we just covered. Basically everything that you'd need to collect from an EPC or any other vendors that are supporting development of the facility to package sufficient evidence for demonstration of compliance with these requirements is the planned approach and how we can help, as well as just general guidance and training or coordination that may be needed to help all the parties associated with these activities understand what's needed and from who and when. That's what we can support you with, and our planned approach to make sure that you get there at the end of the journey. So those are the next steps, just assessing your facilities, what scenario you might be subject to, and then further discussions around documentation and information that you might need. And then start your technical planning journey to prepare for demonstration of compliance and or putting things in place to ensure you can comply, and making sure all the right parties are at the table to contribute to that result. So yeah, recognize a lot of names on here. I appreciate you joining. I get to work with really sharp folks like Todd every day, so I'm thankful for the opportunity to share that with everyone here today. And we have about 18 minutes. I want to open it up to questions and discussion, as Todd said, to see what else is out there, and if any folks have any technical questions or questions about content that we didn't touch on that we can elaborate on.
Yeah, so everybody should be able to unmute. And we have quite a few questions in the chat. There's a couple that I think I'm going to read. Okay, from a generator owner perspective, what are the most critical operational and compliance risks introduced by FERC Order 901 in the related IEE 2800 and PRC 29 standards, and how should organizations prioritize addressing them? Kind of a long one that we got.
So I guess I'll start this out. Probably the biggest aspect that will have to be looked at is the control characteristics and inverter capabilities of that particular facility, and are they configured? Some of the requirements in terms of reactive power support out of your inverter at an inverter base. I'm aware of that a lot of facilities that were put in place several years ago did not have that capability enabled. So there will need to be a look at your plant controller, your inverter capabilities, and what can and cannot be done in terms of complying with PRC 29, and then start your documentation around what those limitations are and plans on how to make the changes to help support conforming to the extent that's possible.
Okay, awesome. Next question that we got in the chat. Given the ride-through and performance requirements for inverter-based resources, what common design or operational challenges do generator owners face, and what practical strategies have proven most effective in ensuring reliable compliance? Kind of covered this, but yeah, go ahead.
Yeah. So as you're thinking about facilities going forward, utilizing generation for inverters, which are designed to be compliant and capable of supporting this. Power plant controllers, all as far as I'm aware of and see, have the necessary control aspects. So I think technically most of the elements are in place now from an acquisition aspect. One of the gaps that I see is historically I've seen that a geo will go out and contract with 3 or 4 different vendors to provide elements of the system to connect them together with the expectation they will work. As you're rolling forward, there will be a greater demand for an engineering aspect of the overall plant performance and someone responsible for ensuring that those are coordinated properly and work as a system in the desired performance aspect, and rather than being a little less strict on how that integration aspect works.
Okay, great. I'm gonna go ahead and read Jill's unless you want to unmute. Per IEE 2800 in 2022 and PRC 29, which one is more strict, quote unquote, in terms of IBR performance requirements during disturbances, or are there potential conflicts with these two regulations' expectations?
It's a really good question. IEEE 2800 is more comprehensive, so there are elements and aspects that are included that the intent is you would consider them as part of your design elements that are not included as part of the NERC requirements. NERC looking at if we have the performance we're desiring, having details specific to looking at those elements is not necessary. In terms of specifically ride-through elements or aspects, the voltage ride-through performance of PRC 29, and it relates only to 500 kV interconnected systems, is a little bit different than IEEE 2800. PRC 29 is probably a little more forgiving, that after a period of time it allows a little more or it allows more area in a allowable trip zone than what IEEE 2800 does. But overall, they are fairly consistent, and expectation is that if you're compliant with one, you're predominantly compliant with the other.
Okay, great. Next question in the chat from Cavanley. If the plant is a combination of IBR and synchronous generators, would these requirements apply to the IBR portion, assuming common collector substation, or would this type of facility be outside these NERC PRC requirements, assuming the IBR portion meets the Category 1 or Category 2 requirements when considered alone? That's a little bit of a long one as well.
It is, but yes, the expectation is that the IBR elements of the plant would conform to 28, 29, and 30, while the non-IBR elements would continue to conform to PRC 24. There would need to be a little bit of a review from an engineering aspect to ensure that there wasn't a conflict created by the two different response aspects. But yes, you would apply each of them specifically individually to the elements of that combined plant.
Okay, awesome. Next question from Chris. For PRC 30, what will an auditor look at to determine if a facility had a loss or drop as characterized by R1?
So part of R1 is yeah, you identify those losses, and your predominant tool is likely going to be your disturbance or your disturbance data. It's part of PRC 28 and monitoring that for drops. That data likely goes away, so you would then be relying on SCADA information to validate or identify times when you saw plant output drop. And if you haven't identified, yeah, I expect that there will be somebody looking to see should you have identified something.
Okay, great. Next question from Daniel. Do you know if the CAISO Appendix H event transient data recoding requirements in alignment same as PRC 28?
Could you ask that question again?
Yeah. It says, do you know if the CAISO Appendix H event transient data recoding requirements are in alignment or if they're the same as PRC 28?
So they are not the same as PRC 28. They are actually a little more stringent, a little tighter requirements than what PRC 28 meets requires. But what I have looked at, I believe if you meet the CAISO aspect, you will meet or exceed the requirements of PRC 28.
Okay, awesome. I think that's all of our questions. Unless anybody else wants to unmute or ask them in the chat, I can read them out loud. But thank you all so much for coming and joining in on today's Lunch and Learn. We hope you enjoyed it.